Hi all, now we are going to see how to combine and merge two different data sets. The combining of two different data sets can be done by adding pandas.merge, pandas.concatenation or combine first. Let us see how it can be done in detail. So first, to do the merge, we should know what are the different type of joins available. Here we have four type of joins: inner join, outer join, left and right join. When you talk about inner join, that is the intersection. You can see here when you have two different data sets, the common one will be projected, whereas the outer join is showcasing the entire data available in the two sets. Whereas when you take the left join, it is going to prioritize the left side or the first data set or the data frame, and just checking what are the common data from the second set and also showcasing that, and the remaining will be NaN values. Likewise for the right also, it is about the second data frame or the second data set. And by default you'll always have the, if you don't mention any type of join, the default will be an inner join. So here it is a simple example by which we'll understand the joins, different type of joins. We create a data set or data frame. First one is about the employee details. We have the ID here, name and salary and age. So this is the data frame 1, and the data frame 2 will have the ID, name, whereas with three other details describing about the department, location and the position. Now here the ID and the name are common here, or somewhere it is same. It is like ID 3 and 4 will have the names as Charlie and David, which is the same for both data sets, and the remaining are entirely different. So first we'll have this two data sets. With this we'll be trying to understand how the different type of joins work. As I mentioned, if you don't specifically tell what to be done, the default one will be inner join, and the remaining are, so for that we'll give it as inner, outer, left and right. So it is the inner join that we are going to project. So pd.merge, the two data frame labels are given on ID. We work it on ID and how it is actually inner. So ID is showcased first, and the remaining are, the name is available in both the frames, data frames, and so we call it as name X and name Y, for an understanding that this is for the data set from data frame 1 and this is from the data frame 2. So name X represents Charlie and David. Same Charlie and David is available in the name Y because these two are common in the two data frames, as well as like the ID, and the corresponding details for the salary, age, location, department, position from the two data frames are displayed here, because this inner will showcase only the common details. Whereas for the outer join, it is going to represent the full content. So ID is first available, the name X, salary, age from the first data frame, name Y, department, location and the position from the second data frame. You can observe here for the Charlie and David, all the data will be available in all the columns, for all columns, whereas for 1 2, which is available in data frame 1, will have the contents or the details in salary and age, whereas it will not be available in the corresponding columns like name, Y, department, location and position and values, because there is no such value available in the data frame 2. Likewise, when you move on to the index or ID 4 and 5 and 6, here the name X, salary and age are NaN values because there is no such detail available in the data frame 1, whereas this entire detail are available in the data frame 2. So when you combine or when you join, if it is an outer join, the whole content will be represented with a NaN value. Let us check for the left and right join. So left is actually prioritizing the first data frame. So it is ID 1, 2 and 3 and 4 is given here, and all the name X, salary and age are available. Coming to the next data frame details, name, Y, department, location and position, other than the ID 3 and 4, remaining will be NaN as we observed in the outer data frame. Same will be done in the data frame 2, or in case of right join. So it is 3, 4, 5 and 6 ID will be present because we work it on ID and we just do it on the right join. So Only for Charlie and David, all the details will be available, whereas for the remaining two in IDs, the first three columns will be of NaN values because there's no such detail available. And remaining columns will have the details because it is available in the data frame too. So inner join is the default join, and it prioritizes or showcases the common details, whereas outer join will entirely represent the represent the entire two data frame details with NaN values. Left is prioritizing the first data frame, whereas right represents the or as a showcase with the base of data frame 2. We can check based on this, we can check what are the possible ways of comparing or detailing in the different joins. So does it keep all the data frame 1 value? No. Does it keep all data frame 2? No. And it just only have the common values? Yes. Does it include NaN values? No, because there's no NaN value when you have the common value. Whereas other than the inner, we'll have the common NaN values in all the remaining three joins. And here, of course, in outer, we'll have both data frame 1 and data frame 2 all details, whereas it doesn't have the common detail alone. For the left join, same no will be there because for there's no common detail. It is only about the data frame 1, so it will not have the data frame 2 details. And the opposite one will be done in the right because in data frame 1 will have data frame 2 details will be available here, whereas data frame 1 will not be available, and NaN values will be available here. Now we'll check this merge with another example. So first we create two data frames, data frame 1 and data frame 2. So this is the index and this is data 1 and key values, and this is data 2 and key values. Now we try to merge, we didn't give anything, we didn't specify anything. So obviously, as I mentioned, default will be the inner join. So it will take only the common values. So A and B is common in both the data frames, whereas C is available in data frame 1 and D is available in data frame 2, which will not be available here. And the key is present here, the common one is present here, whereas data 1, the values for A is actually 2, 4 and 5, that is available for data 1, and for the second data frame it is 0, so it is available as 0 here, and for B it is 0, 1 and 6, so this is what is given in the data frame 1, and for data frame 2 it is only 1 because it's available here. C and D is not common, so it is excluded because we have not mentioned what and how it has to be done. Now on key we have given, so the same like last time, the example that I've shown previously is done here, data 1 and data 2. It's the same like on key, and if in case I give the left key and right key, then obviously it will be created as left key and right key if we create a data frame with left and right. So separately it will be showcased, else it will be just shown on just key. If I have only key as the a label for both the data frames, then I have to give on as key. If in case I create a L key and R key with two different labels, then I have to do it on both L key and R key. So these are the different arguments and the corresponding descriptions, left, right, how, on what basis you're going to do it, on which particular column name you're going to do it, left on, right on, the keys that is available in the particular data frames, left index and right index. Again, it just represents the particular data frame index, sorting, suffixes and copy. So here this is one another example which is given to understand the inner, outer, left and right. So we create a data frame with bowler batting and bowling statistics, and here you see this is the index value and this is the player, team and runs, player, team and wickets. So here the names are player and team are common, and when you put it as merge, default will be the inner, and so it is Smith and root are common in both the cases, so it is available. When you merge, it is just this team, runs and wickets, so it is available here. When you do it on player, then obviously you can see inner on how is inner, so player, team X and team Y comes here because I have mentioned on player, whereas team name the label is common, so team X is for the first data frame or batting statistics, team Y represents the bowling statistics. But if you don't mention on what basis you do, then it is going to be the just common label name will be available as such. And out, if it is left, it is entirely based on the first data frame. So it is player X, then I'm sorry, player team X and runs, and you'll have the team Y and wickets here. Since I don't have any values for the Virat and Rohit in the second data frame, it will be NaN values, and remaining will have the entire data. This will be the same for the right and outer. For the right, it is of the second data set, so it's about bowling statistics. So player, team X, team Y and wickets will have the entire data, whereas in team X and runs, for the uncommon values like Smith and Root will have the entire data, whereas Bumrah and Stark will not have any values, which is NaN filled by the NaN values. Outer will have the entire set, but whenever it is not common, obviously it'll have the NaN values. That's it. Okay. Next is showcased with an example of in place value true. So if whenever you have the, we actually rename the player to batsman here. So here this becomes the batsman and here it is just the player. Now if it is in true, we have to change wherever it is player in this first one. TF means first data frame. It is only one place, so you just change it as batsman. And now we just perform. So it will become as batsman in place. I mean, wherever you have the index as batsman, that will be represented and player will be represented, and you make it as left index and right index. This is the example for the left index and right index. Now it is next is merging on index. So I mentioned about left index true, right index true. This is another example where you can see based on the index it is going to work. Now concatenating along an axis. So first we create a data frame. We actually shape it by 3 rows and 4 columns. So 3 rows, 4 columns is created, which is actually the name of array. And then what we try to do is we try to concatenate. If the axis is 0, then it is row wise. If it is axis 1, then column wise. Like in the reshaping and pivoting also. Level 1, level 0 represents the inner level or the higher outer level, which we seen in the previous in another video in the channel. You can check it. So it is axis 1 represents the column wise, whereas axis 0 if it is given or default it represents the row wise. So since I concatenate the row array 2 times, because it is just going to get added, and I'm arranging it in the axis 1 means column wise, so first array and second array. In case if I don't mention it, it will become this and this. There will be one more set here, array here, because it's array row wise. So it is axis 0, so here and here concatenation is done in row wise. So these are the different arguments and descriptions as given here. Next, combining data with an overlap. So it is actually combined first. Naturally it combines the column by column, so it is like well understood with an example. So we created data frame 1 and data frame 2 with indexes ABC, and data frame 2 is AB with all these values. Now when you combine first, it is actually df1 is combined with the details that is available with the data frame 2. So when I do like this, see, you can have this A, B and C here, and corresponding values are 1 for A, it is 1 NaN and 5 NaN. That's how it should be. Yeah, but again there is a NaN, 2 NaN and 6. But let us check what happens because of this combine first. Now it is A. I'll check with the combine. Already I have 1, so it will be represented, and I don't want to combine the value that is available in the data frame 2 5 to be in the first one, so it is just 1 here. Whereas in the second value or the element is NaN, so it is checking here, yeah, I have a value of 4, so 4 is given here for the A key. And next is 5 and it is NaN here, so 5 itself has been represented. Next is NaN and 3, so 3 is given here, and I don't have any other value here, but I have a value in second data frame 7 that is also available, because I'm combining whatever is available in data frame 2. If there is a space, if it is NaN value, missing value, or it's free, there's no value, obviously I'll put that from the data frame 2. So that is happening here. Same way for the B. I have nan value here, so it is also nan here. I can't fill anything, so even the data frame 2 it is nan, so it is only nan. 2 and 3, so it is 2 already available data, whereas nan and 4, so 4 will be taken from the second data frame to the first, and 6 and 6 is 6, whereas I don't have anything here where I have 8, and so 8 is available here. And C is, I've just created a range of 2 to 18 with a step value, skip value of 4, so it's 2, 6, 10, 12, 14 and 18. Since 18 is given here, it is excluded, so till 16 will be 14 will be given, and so it is 2, 4, 10 and 14, and the last one is nan value. This is another example. So two different values, you can check wherever there is a nan, it is filled. Here it is nan, I have 20, this is filled. Again there is a nan, it is 40, it is filled. There's no nan here, so same value. Here it is nan 70, and here it is nan, so 90. But if in case I have nan in both the cases anywhere, then it is going to be the nan only. Thank you.